Coming to the topic of scaffolding in the blast furnace, and it is one of the very important aspect of blast furnace stability. Coming to the symptom, then we can see that the scaffolding in the blast furnace is doubted. And in these conditions of, or we can say in presence of a scaffolding, these are the symptoms that will be visible. That is, intensity of heat flow through the furnace wall will decrease, and this can be traced by the low temperature of the furnace walls. That is, in such cases, the stave body temperature. If you look into, then we can see that really there is a decreasing trend. Another aspect of analyzing presence of scaffolding is water temperature differences over a period of 2 week or 3 week or a week, or we can say or even 3 days. We can see that if a scaffold developed at a various level of the blast furnace, then there is a decrease in outlet water temperature of cooling members, and this also gives a symptom. At the same time, with the accretion, uh, shell temperature also can be traced with a laser gun or thermovision cameras to trace the presence of scaffolds. And scaffolds is present over a area of a stack, then our distribution is severely damaged. And in such cases, uh, we can see that there is a level difference of a stock rod, and it keep on increasing or followed by a slip, or then again going apart. So we can see that presence of this type of scaffolds will lead to a difference in stock line mm, measurements from the two source. That is, once again, we can summarize that if we have got a radar and mechanical, of course, calibration is must look into that it should be right. And if you see, compare two radars at two different angles, then we can see that there is a difference in stock lines. And due to this presence of accretions, uh, distribution also gets changed, it's getting reflected in a stock line difference. And here we are observing this analysis to corroborate the presence of such type of accretion. Actually, towards the accretion, less gases will be go there, and most of the ore will be rolled towards the other side of accretion, and in process, our CO2 content in that side will be higher compared to the accretion. This is being also shown in the graphical trend to keep track of presence of such type of accretion. So we can say that presence of accretion also changes in the gas distribution, and such type of gas distributions is leading to slipping and breezing. So furnace never becomes stable, and uh, there is always a process upset. And as we said, due to these process upset lead to low utilization, difference in the stock rod is a clear indication of it. Of course, there is a final product also has a variation, that is, if you see the silicon ones like basicity, there also we will have a lot of fluctuation. And this fluctuation is also uh, is telling about a lot about the scaffolds, and such type of a breathing and sleeping also leads to channeling, and thus we can say that the uh, process upset is uh, accompanied by so many mm, problematic areas like burden descent, uneven utilization is bad, the final product variation is there, and uh, so many problems. Now, coming to the lower area and the scaffold linkages on it, that is, at the heart, if such type of occasional slips, unprepared material doesn't occur, then really our heart is going to also have effect. And in such cases, a lot of heat will be sink, and because from the upper areas unprepared burden is going to participate in heart without getting processed, and that takes a lot of it. Similarly, cold cooking also, due to consequences of this slips, is coming to the raceways and creating a cold situation. And in totality, we can say that a heat sinking situation leads to slack flooding, and many times it can fill the tuyer also. So we can talk about here the most important thing about the scaffold, that is about the operational characteristic, and which is directly linked with the top temperatures. And once we come across the top temperature observation, then we can follow some two, three very key points which will always gives a huge guidance in diagnosing that what type of scaffolds and what sort of its intensity is there. And the most important thing is that in all course of its presence, your optic temperature remains high. So, and once high optic temperature, it will always have a low utilization, but annular creation will really confuse us, because in annular creation, if we see the all four optic temperatures, then they will look very alike, not difference as in the previous cases where we have got a asymmetric accretion. And for a local equation, also top temperature varies from direction to direction, and it is easy to take care, and it is easy to diagnose that yes, there is a accretion. And now coming to one of the symptoms, that is a dust generation. Uh, we see in dust catcher our dust getting accumulated on a higher amount. If we maintain day-to-day basis of this data. The idea is that due to this aggression, the cross-sectional area reduces and gas escaping with a huge velocity. And when it comes in contact with the burden of having same strength, which were being used in normal operation, come across a huge kinetic energy, which the fragment the burden, and a lot of fines generated. And these fines getting transported to our dust catcher, which gives a reflection that dust output increases. Now, as for the formation of accretion, as scaffold is concerned, an upper part and lower part, it is look short of, strata short of. But in the lower region, really, it is very tough, and in lower region, it is formed from the solidus and from the liquidus of your iron. So it is very tough, and such type of accretions are very difficult to take away. Now, coming to the area, the activity which also helps in forming such accretion very fastly is basically the low temperature activities on the top of the furnace that we used to invite, like low stock line running, sleeping of the furnace, charging after checking, or charging after blowing out, weight burden formed by grouting or lining, or burden weighted by stave leakages. This all leads to or create a low temperature zones in the preparatory area, that is the primary area or preheating area of the blast furnace, and this is the most provoking um, activity for scaffolds. And before taking action to take out, roll out, or treatment for the accretion, we must have to locate it, which can be done by the heat transfer calculations. And we must have to see across the cross section what is the heat transfer, or we can also visualize or you can corroborate its earlier activity by lowering and opening the hatch cover to see the presence of such type of scaffolds at what elevations that can be identified. And about the solutions, there are accretions which are on a many area of the stack. Sometimes they automatically fall, and really we are lucky in such situations. And but many times we have to flush it, and flushing means we have to put a coke which descend into lower region, and with the sensible heat it carry out a lot of high temperatures which treat the area of scaffolds. So we can say that it's basically conveying a high temperature from the raceway, from the burning of the coke to the stack region where our accretion is there. So at this in such situations, operator has to uh, create its periphery open. That is, its periphery wall region should be more permeable, or we can say from there we can take out a lot of hot gases to take care of the accretions to develop. And similarly, with the treatment of a scaffold, sometime also done by lowering of stock line, and many time it is also seen that by treatment by flashing also not possible. At that time we low down it to, and one of the recent experience is about 10 to 11 meter burden, where when burden taken to almost 10 to 11 meter, this scaffolds fallen. So we can say that this is also one of the solution to take care of accretions. So now the coming to the gist of this presentation is that of course the material should be good, whatever input material that we are using for blast furnace. We should have a balanced gas distribution which will be purely guided by the utilization or ETASIO we can say, and we must have to see the permeability of our stock column, and for that we must have to take corrective measures. Really, if we have a fines increase and it's something go on increasing, we have to check whether our oversizes or undersizes within the stipulated band, whether the perforations are okay, whether the apertures are rightly engineered, and so many things. And hot conditions to be activated, and we have to maintain the furnace stability, with a minimum process upset. And some 2 3 points that needs to be highlighted in context of accretion is that we have to prevent the operation at low stock line, that is must. Water leakage is absolutely is to be avoided. We have to control the belly and lower shaft temperatures, and especially in this area average temperature of the stave body level could be a very good symptom for any operators. And it is also being noticed from other bigger companies, those who keep the average temperature of their stave body level and belly, Bosch and lower shaft region to correlate whether those are in a right band or not. That is on a right temperature difference band or not. So that it always rule out any deposition. And the most important is a stable operation. That means we have to aim our chemistry consistent. That is consistent silicon and right basicity. And finally, I will say thank you very much for listening.